Hi! This video is a continuation about activation energy, but this is very specific. We'll look into the factors that influence activation energy. You know that activation energy diagram looks like this, and you see that in this diagram, there can be changes in the curve. In other words, the activated complex, which is the maximum energy that needs to be reached so that the reaction will go into completion. So, what is it that influences activation energy? We will look into the effect of catalyst. What is a catalyst? A catalyst is a substance that changes the rate of the chemical reaction, but it's not being consumed in the reaction. How do we think about catalyst then? We can think about catalyst as bridge. They will bridge the meet up of the reactants so that they will speed up or they will meet at a shorter period of time. Therefore, they can bond and create the products. Without the catalyst, there will be no bridge that will speed up the meet up of your reactants. So, in other words, the catalyst is instrumental to make the reaction take place faster because it's the bridge that will allow your reactants to interact and be able to form new chemical bonds that will form new compounds. So the moment you see in this diagram, the moment you have a catalyst, the moment the reactants form a product, then you see that the catalysts remain the same. They're not part of the chemical reaction technically because they don't destroy their bonds, they don't create new bonds. They are just the, the instrument to be able to make your reactants form the products at a shorter period of time. So, how does a catalyst influence activation energy? It actually lowers down. So example of the catalysts are actually our enzymes. These are natural catalysts for living organisms to make the organic reactions in our body to take place faster. Some of the enzymes are even found in the saliva. So what does it do to the energy? So if you see here, you have two curves. You have green and purple, and the purple is the uncatalyzed reaction, while the green is the one for catalyzed reaction. Nothing changes except the activated complex of the two. The uncatalyzed is higher, so the EA here is big, while for catalyzed reaction, it's shorter, therefore it requires smaller activation energy and it reaches the activated complex area at a faster time. But the initial and the final energies remain the same. So that is the effect of catalyst on the activation energy. So that's it. This is just very short. I want you to watch out for the next video in which we're going to determine the catalyst and the intermediates for sequential reactions. This is Madam Narca saying don't stop learning, relearning, and unlearning. Please subscribe to Narcademy and follow it in Instagram. Bye for now. Bye bye.